Hello my dear students, welcome to another PYQ discussion session by Brilliant Khatar. In today's video, we are going to discuss most important JEE main questions from the chapter waves. Here comes the first question. Speed of a transverse wave on a straight wire of mass 6 gram, length 60 centimeter and area of cross section 1 millimeter square, okay, is 90 meter per second. So the speed is given as what? 90 meter per second. If the Young's modulus of the wire is 16 into 10 to power 11 Newton per meter square, the extension of the wire over its natural length is, okay. So this question is directly connected with our chapter properties of solids also, okay. And in addition to that, the speed of a transverse wave through a stretched string. So it's a multi-concept question. So we all know that stress by strain, that is equal to Young's modulus, and stress is F upon A and strain is delta L by L, that is equal to Young's modulus. Okay, stress is F by A, strain is delta L by L. So I believe you understood how I wrote this. From here I can say delta L, that is equal to FL upon A into Y. Alright. So let me hold this equation. Now we all know that through a stretched string, the speed of transverse wave V is supposed to be under root of T divided by mu, or I can say root of T upon what is mu? Mass upon length. Okay. Now let me square this. V square, that is going to be T into L all upon mass m. From here I can say capital T, that is equal to V square into m all by L. So I have got the expression of T now. Now let me substitute this value here. T is equal to force F. So delta L is now equal to L upon A into Y, okay, multiplied by, instead of F I can put what? V square into M, V square into capital M all divided by L. So L and L will cancel. Now we have got the elongation delta L, that is equal to V square into capital M all divided by A into Y. Alright. Now what is V square? V square need to be marked as 90 into 90. So I am going to mark it as 9 into 9, okay, into 10 to power 2. Or into what is mass? Mass is 6 gram. That is 6 into 10 to power minus of 3. Okay, all divided by, what about area? Area is 1 into 10 to power minus of 6 into, what about Young's modulus? Young's modulus is 16 into 10 to power 11. 16 into 10 to power 11. Alright, now this can be written as 9 into 9, that is 81 into 10 to power 2 into, let me write this as 3 into 2, okay, into 10 to power minus 3 all divided by, here I can write this as, 8 into 2, okay, into, on denominator we are having what? 10 to power 5, isn't it? 10 to power 11 and here this is 10 to power minus of 6. It's 10 to power minus 5. Sorry, 10 to power plus 5. So here these two will cancel each other. Okay, and what I am now left with is 81 into 3. Okay, so 81 into 3 is supposed to be here, this is 3 and here this is 243. And 243 all divided by, here it is 8. This need to be 24, 0, alright. 3 will be coming down. Of course, here this is going to be 0, again 3, 24. Alright. So, here this is going to be 3.3 into, here this is now going to be what? 3.3 into, here I am having 10 to the power minus 1, alright, and this will be coming to the top, this is going to be 10 to the power minus of 6, alright. Okay, now comparing this with my answer, it should be 0.03 mm. Alright, moving to the next, question number 2. 3 harmonic waves having equal frequencies nu and same intensity I naught have phase angles 0, pi by 4 and minus of pi by 4 respectively. When they are superimposed, the intensity of the resultant wave is close to 2. Okay, now they are having same intensity, so they are having same intensity means they must be having same amplitude also. Now the phase difference is given as 0, pi by 4 and minus pi by 4. So let's understand this situation here. Let me represent these waves first. Okay, in the form of a phasor diagram. I repeat, in the form of a phasor diagram I would like to represent. So let this be the 2 reference and let this be the first wave and let this be the second one, alright, and let this be the third one. So here the amplitude is capital A, here also the amplitude is capital A, and for this one also it is A. So here this is pi by 4 and here also it is what? Pi by 4. Let me name this as 1, let me name this as 2 and let me name this as 3. Now what I am going to do is, let me take the resultant of 2 and 3 here. I am going to take the resultant of 2 and 3. So the resultant amplitude of 2 and 3, that is supposed to be root of A2 square plus A3 square plus 2 times A2 A3 into cos of phi. Here what is phi? Phi is 90 degree. Between these two angle is 90 degree. So of course this part is going to be what? 0 here. So resultant of A23, that is going to be, here this is a root of A square plus A square, that's going to be what? A root 2. Okay, and in which direction it is? It is in the direction of this. So root 2 times A is now here. Now this is no more existing. I am considering these two. Alright. Now what about the resultant of these two? So the resultant of these two, I would like to mark it as A naught, that is equal to root of A23 square plus A square plus 2 into A23 into A into cos of phi. Here what is cos phi? Cos phi is equal to 1 because phi equal to what? 0 here in this case. Alright. Now taking this ahead, A naught is supposed to be root of A23 square, this one. Okay, that is going to be 2 times A square plus A square, okay, plus 2 into under root of 2 times A into A, it's now going to. Again we know that capital A is common, that will come out. Here this is going to be 2, here this is going to be 1, and here this is going to be 2 root 2. Okay, fine. Yes. We all know that root 2 is 1.414 multiplied by 2. Here this is 4 2s are 8, 2, 8 and 2. So it's going to be 2.828 plus I have got 3 here. So plus 3. So here this is going to be 5.828. It's 5.828 root of. So the resultant amplitude A naught, that is coming as A into root of 5.83. 828, I am marking it as 83. Now we all know that the intensity I is equal to K into what? A naught square. So here this is I equals K into A naught square means A square into 5.83. Here this is intensity of one wave, isn't it? And it is marked as I naught. So I can say the resultant intensity here is I equals to 5.83 times I naught, which means option D must be correct answer for me. All right. Yes. Now let's move to the next. That is question number 3. Question says, two identical strings X and Z made of same material have tension Tx and Tz with them. So tension in X is Tx and tension in Z is Tz. If their fundamental frequencies are 450 Hz and 300 Hz respectively, then the ratio of Tx and Tz should be. Okay. So let's try to understand the fundamental concept first. This is the fundamental, this is the case where I can have the fundamental frequency of a fundamental frequency for a stretched string. And here you know this length of the string L, isn't it? Two identical strings, fine, the length is same for both. So the length of the string is nothing, it's lambda by 2. Alright, yes. What we know about lambda? Lambda is equal to V into T, or lambda is equal to V upon frequency F. Yes, now what we can write is, instead of lambda, I have got this expression. Okay, what it is? L equals 1 by 2 into, instead of lambda, what I have? V upon F. Okay, fine. Rearranging this, I may write this as 2 times F into L. I repeat, 2 times F into L, that's equal to what? V. 2 times F into L is equal to V. Or I can say F of X upon F of Z. That is equal to V of X upon V of Z. Because while taking the ratio, since the length is identical, this will cancel each other. Okay. Now, what is F of X and F of F of X as well as F of Z? The frequencies are given as 450 and 300. So here this is going to be 450, okay, divided by 300. That's equal to, what about this? Here this is root of Tx upon Tz, because V equal to what? Root of T by mu. Since the strings are identical, mu is going to be same for both. Okay, now let's go for this now. Of course, this one and this one will cancel each other. Now here this is 45 can be written as what? 15 into 3. And 13 30 can be written as 15 into 2. That's equal to root of Tx upon Tz. 15 and 15 will cancel. Alright, squaring this, 9 by 4, that's going to be Tx by Tz. And 9 by 4 is what? 2.25. Option B must be correct answer here. Alright, now let's move to the next, that is question number 4. Question number 4 says, in a resonance tube experiment, when the tube is filled with water up to a height of 17 centimeter from the bottom, it resonates with a given tuning fork. When the water level is raised, the next resonance with the same tuning fork occurs at a height of 2.4 centimeter. Then the velocity, if the velocity of the sound in air is 330 meter per second, the tuning fork frequency is. Let's understand the situation here first. Let this be the tube. Let this be the tube. Okay, you must understand this as an open tube only. Okay, let me draw it like that. Okay, these are the two walls and here this is the base, and the waveform can be drawn like this. Ignore the perfection. Okay, let this be the height of water. So here, as per the question, they say that this much height is marked as how much? 17 centimeter. Okay, now next time the resonance will occur if you raise the level of water up to here. Okay, and this time the level of water is marked as how much? 24.5. 24.5. Okay, so definitely what is this difference? 17 plus 3, 20, and 3 plus 4.5, it is 7.5 centimeter. 7.5 centimeter, and it is crystal clear, this 7.5 centimeter, that's equal to lambda by 2. That's equal to lambda by 2. Is that fine? Because this part is what? Lambda by 2. This length is equal to lambda by 2. Now the same relation. Lambda is equal to V upon F. Okay. Now this can be written as 7.5 into 2, that is 15. So 15, that's equal to lambda. I mean here this is 15 centimeter. Lambda equal to 15 centimeter. And what we have lambda? Lambda is V by F. So 15 centimeter, that's equal to V by F, or I can say frequency F, isn't it? Frequency F need to be equals to what? V upon 15. 15 centimeter. And what was V? V was marked as 330 meters. 330 meter per second, all divided by, here this is going to be 15 into 10 to the power minus of 2. 15 into 10 to the power minus of 2. Now I may write this as, moving to the next page for the calculation. Here I can mark 33 as 3 into 11 into 10 into 10 to the power 2. How this 10 to the power 2 came? This came to the top. And on the denominator we have got 15. There I will mark it as 3 into 5. This 3 and this 3 will cancel. This one and this one will cancel, will leave 2 there. So now it is 2 into 11 into 10 to the power 2. That is 2200, which means it should be option C. Now let's move to the next, that is question number 5. Two traveling waves produces a standing wave represented by the equation y equals 1.0 millimeter into cos of 1.57 per centimeter times x into sine of 78.5 per second into t. This can be compared with the relation a cos of kx into sine of omega times t. Okay, now what is kx? Kx equals 1.57 per centimeter into x. Alright. Now if we want a non-displacement portion, that is a node, cos of kx need to be 0, and for the first time it is possible at cos theta equal to pi by 2. So I can say that 1.57 into 10 to the power 2, 10 to the power minus 2 raised to minus 1, 10 to the power 2 times x is going to be pi by 2. And we all know that here this is 1.57 into 10 to the power 2 times x. I may write this as what? 3.14 by 2. Alright. So of course you all know that 3.14 by 2, that is 1.57. 1.57 and 1.57 will cancel. Okay. Now if I take this towards the left, x is supposed to be 1 upon 10 to the power 2, or I can say it's 10 to the power minus of 2, isn't it? So in centimeter, if I want to say, x need to be marked as 1 centimeter, so at here at the gap it should be 1. Alright, fine. Moving to the next, that is question number 6. Question number 6 says two waves are simultaneously passing through a string and their equation is given as y1 equals what it is, a1 into sine of kx minus v times t, and y2 that is coming as a2 into sine of k is there, no? K is common for all. So it should be k into x minus of kvt, and here this is a2 into sine of k times x minus vt plus x0. Okay. Now amplitude is given as a1. A1 is given as how much? It's 12 millimeter. And what is a2? A2 is given as 5 millimeter. Alright. What about x0? X0 is given to us as 3.5 centimeter. 3.5 centimeter, and the wave number k. Wave number k is given as what? 6.28 per centimeter. What they are asking towards us is the amplitude of the resultant wave. The amplitude of resultant wave. What about the amplitude of resultant wave? If I want to write this as a naught, that means the amplitude, it should be root of a1 square plus a2 square plus 2 times a1 a2 into cos of phi. We are okay with the value of a1, we are okay with the value of a2, so of course this part is also done. Problem is with the value of phi. Okay, now what need to be the value of phi here? The value of phi need to be equals to, see, have a look at this particular expression. If this k goes in, the value of phi need to be k into x naught. That means what we have here for k? K is basically 2 times pi, because it's 6.28, that is 2 times pi, okay, into what we have here for x naught. X naught we have it as 3.5. I would like to mark it as 7 by 2. So 2 and 2 will cancel. So phi is equal to 7 times pi. Odd multiple of pi is supposed to be, and cosine of odd multiple of pi, it is supposed to be minus of 1. That means this particular part need to be negative. Okay, so considering that and taking to the next page, a naught, that is now going to be a1 square plus a2 square minus of 2 times a1 into a2. I believe how this minus came, you know, isn't it? It came from that cos theta term. Now let's substitute the value for a1 and a2. Okay, now this is supposed to be root of a1 square. It's 12 square, that is 144. 144 plus a2, a2 is 5, square of that is 25, minus of 2 into a1 is 12 and a2 is 5. Alright, so here this need to be what? 5 2s are 10, 10 multiplied by 12 is 120. So here this is 144 plus 25, it need to be 169, isn't it? 5 plus 4, 9, 4 plus 2, 6, yes, 169 minus, here this is 120. Here this is root of 49, which is supposed to be what? 7. Okay, or we were expecting all values in terms of what? We were expecting all values in terms of, millimeters only. So of course here it is supposed to be what? 7 millimeters. I believe you got it right. Okay, yes, moving to the next, that is question number 7. The question says a wire having linear mass density as 9 into 10 to the power 4 kilogram per meter. So the linear mass density lambda, that is given as 9 into 10 to the power minus of 4 kilogram per meter. Alright, is stretched between two rigid support with tension T equals 900 Newton. Tension T is equal to how much? 900 Newton. Wire resonate at a frequency of 5000 Hertz. So the frequency at which it is resonating, that's equal to what? 500 Hertz. The next higher frequency at which the same wire resonate is 550. Okay, so here this is F1 and let me mark the next frequency as F2 and they are marking it as what? 550 Hertz. Now the length of the wire is, that's a question. Let me consider this as the fundamental frequency. I am just considering a situation here and the next possibility is this one. That is the first overtone. I am just considering it like this only. I will tell you what is the key reason behind this. So for the first one I can say that capital L, that is equal to lambda 1 by 2 and for the second one capital L is equal to lambda 2. Okay, for the second one it is lambda 2. Now we all know that lambda, that's equal to V by F. So if I consider the first situation, here I can say 2 times L, that's equal to, instead of lambda 1, I am going to mark it as V divided by F1. 2 I consider over here. And for the second one, I am going to have it as capital L, that's equal to lambda 2, that's equal to V divided by F2. Now have a look. What is F1 here? F1, that's equal to V divided by 2L and F2, that is equal to what? V by L. So here it is V by 2L and here this is VL. So what is the change in frequency? Change in frequency is V by 2L. Okay, so delta F, I can mark it as V by 2L. So change in frequency is going to be V divided by 2L. Now from here, what is change in frequency? Change in frequency is just 50 Hertz. So 50 is equal to, what's supposed to be V? V is supposed to be under root of T by mu. Okay, so delta F is equal to V, that is under root of T by mu into 1 upon 2 times L, isn't it? And we need to get the length. So for the calculation, moving to the next slide, I can say that capital L equals to 1 upon 2 into 50 into under root of T by mu, that is 1 by 100 into under root of, what was capital T? Capital T was 900. Okay, all divided by, what is mu? Mu is 9 into 10 to the power minus 4. 9 into 10 to the power minus of 4. Isn't it? Yes, 9 to 10 to the power minus of 4. Rearranging this, I can have it as 1 upon 100, okay, into, of course, here this will go to the top, okay, that is supposed to be what? 10 to the power 6. So here this is 9 into 10 to the power 6, all divided by 9. This one and this one will be cancel each other. This is going to be 10 to the power 3. So 10 to the power 3 by 100, it should be what? 10. So here the answer is 10 meter. Alright. Now let me come to the point. Here I started with the fundamental frequency. Okay, you can start with the first overtone also. You can start with the second overtone also. Second overtone followed by third overtone. That is the only thing that you must understand here. And for all the case, delta F is going to be V divided by 2L. So that was the key concept here. Now let's move to the next, that is question number 8. Question 8 says, a closed organ pipe of length L and an open pipe contain gases of densities rho 1 and rho 2. So I am having a closed organ pipe and an open organ pipe. Let me consider this as the closed organ pipe and let this one as the open one. Here the density is rho 1 and here the air density is rho 2, and both are having length as the same. So I need to mark it as the same length in this way. Now the compressibility of the gases are equal in both the pipes, which means beta is same for both. Beta is same for both. Beta is same for both. That's most important. Now both the pipes are vibrating in their first overtone. That is very important. Both are vibrating in the first overtone with same frequency. Frequency is the same. Okay, so that is also an important information. Frequency is the same. Frequency is also the same. Alright, now the length of the open pipe is, so here this is LO and here this is, okay, here this is for the closed pipe. For the closed pipe it is L, for the open pipe it's LO. So we need to find out LO, and it is given as what? X by 3 times L into root of rho 1 by rho 2, where X is, yes. So I in the beginning I said the length is same. No, I'm sorry for that. We need to find out the length of the open pipe. Okay, now for both the pipes it's first overtone. Okay, so for the closed pipe, if I want to mark the first overtone, then I need to mark it like this. This is going to be the first overtone for the closed pipe. Okay, now for the open pipe, if I want to have, I must have it something like this. This is going to be the first overtone. Okay, so here this is 1, 2, 3, 4. So it is L suffix O, that is length of open pipe is 4 times lambda by 4, that is lambda. Alright, okay, yes. And for the closed pipe, I am going to mark the length as L here, that is 1, 2, 3. So that is 3 times lambda by 4. Alright, that is for what? Here this is for open pipe and here this is for the closed pipe. Alright, frequency is same for both. So we know that lambda is going to be V divided by F. So let me substitute that here now. Okay, so for the open pipe L suffix O, which was equal to what? Lambda, I will mark it as what? V by F. And for the open the closed pipe, for the open pipe density was rho 2. So here we are marking it as what? The open pipe na. So for the density here it is rho 2. So here I am going for this particular relation L suffix O, that is equal to V. What is V? We all know that V is equal to under root of beta by rho. So here this is going to be 1 upon F into under root of beta divided by rho 2 for the open pipe. And for closed pipe, that is L, we must have it as what? 3 by 4 times lambda, isn't it? So 3 by 4 times, instead of lambda, we know that it's going to be what? V by F. Okay, so here this is 1 by F into V is going to be root of beta divided by rho 1. Alright. So from here I can say that for the open pipe frequency FO, it's supposed to be what? Root of beta upon rho naught, okay, into 1 upon LO. And for the closed one, here this is F suffix C, that is equal to, rearranging this, I can say that 3 divided by 4 times L. For the open pipe, for the closed pipe we are maintaining the length as what? L. So L came over here, F went to the top, under root of what? Beta upon rho 1. Alright, we know that this frequency is the same, that means I can equate these two. So here this is 1 upon L suffix O into root of beta divided by rho 1. Here this is rho 2, isn't it? This is rho 2. Alright, that should be equal to 3 divided by 4 times L into root of beta divided by rho 1. We need to get the length of open pipe, isn't it? So L suffix O, that is now supposed to be, of course this will come to the left, alright, yes. So LO, that is now going to be, rearranging this one, root of rho 1 divided by rho 2 into this, if this is coming to the left, it's supposed to be what? 4 by 3. And here the answer is x by 3 times L, isn't it? So here this L will accommodate here, it will be accommodated here. So L naught, that's going to be what? 4L by 3 root of rho 1 divided by rho 2, which means x need to be what? 4 here. Comparing with the answer, x need to be 4 in this case. I hope you got it right. Now let's move to the next, that is question number 9. Question number 9 says, a sound wave of frequency 245 Hz travels with speed of 300 meter per second along the positive x-axis. Each point of the waves moves to and fro through a total distance of 6 centimeter. To and fro through a distance of how much? 6 centimeter. So the upward it need to be 3, and in the downward direction it need to be 3. Then only it's going to be what? 6 centimeter. That means the amplitude is 3. amplitude need to be 3. That means here it could be considered as an option, as well as here also it need to be considered as an option. These two must be marked as wrong choice. Okay, now what will be the mathematical expression for this traveling wave? That is the point here. Okay, now what all other informations we have is, we are having the frequency. Frequency is marked as what? Frequency is marked as 245 hertz. Okay, now what about omega? Omega is supposed to be 2 pi f. Okay, now this can be written as 2 into 3.14 into what is frequency? Frequency is 245. Now 245 into 2. Here this need to be 5 2s are 10, 1 4 2s are 8, 9 and 2 2s are 4. So 490. Okay. Now here I need to go for 314 multiplied by 49. Alright. So here this is now going to be, so 9 4s are 36, it's left with 3 here, 1 9s are 9, 9 plus 3, it's 12, left with 1, 9 3s are 27, 27 plus 1 is 28, and here 4 4s are 16, 1 4s are 4 plus 1 it is 5, and 4 3s are 12, isn't it? So here this is 6, 6 plus 2 it is 8, alright, and here this is 8 plus 5 it is 13, left with 1 here, and 2 plus 2 4 plus 1 5, and here this is 1. Alright, and how many decimal places? I am having only one decimal place need to be taken towards the left. So it is 1.1538.6, approximately is 1.538 into 10 to the power 3. So that means this part need to be perfectly matching with omega. That means option 4 must be correct answer here. Moving to the next. The question says two traveling waves of equal amplitude and equal frequencies moves in opposite direction along the string. Okay, they interfere to produce a stationary wave whose equation is given by y equals 10 into cos of pi times x into sine of 2 pi small letter t by capital T. The amplitude of the particle at x equal to 4 by 3 centimeter is. So here 10 into this part is what? Basically cos of kx, isn't it? Fine. So here this is cos of kx. Now this is the part which is going to determine what need to be the maximum amplitude for a given value of x from the origin. So if I consider cos of pi into what's x? It is 4 by 3. Okay, fine. So cos of 4 pi by 3. The magnitude of this is what? 1 by 2. So the amplitude is now going to be 10 into 1 by 2, which means it must be 5. Okay, in centimeter it is. So the answer is going to be 5 centimeter. Alright, that's all from my end for this time. Meet you in another video. Till then, bye bye and take care.